Let's get started. Good morning, good afternoon, everyone. Appreciate everyone joining. It's 12 Eastern here in the US East Coast, right out of Washington, D.C. I'm the VP of Product here. My name is Navin Sharma, and I'm excited to bring you a point of view perspective of Stardog featuring our AI data assistant. It's all about helping you accelerate your insights with no code, no dashboards, and no hallucinations, more importantly. So let's get started. From our perspective, we believe that the winners in every industry, especially now in this era of Gen AI, will be companies that empower every knowledge worker with data and AI. And obviously with that comes the challenges that most companies have to counter and deal with respect to how they enable their knowledge workers with access to data and AI. And we know today that data and AI democratization certainly is hindered by costs. It's hindered by the expensive GPU infrastructure that has to be put in place. It's also all the tech debt with respect to where all the data they need in order to provide those relevant insights is located, how it's structured, where it sits in the cloud, where it sits across multiple clouds, where it sits across multiple data lakes, multiple data warehouses. And then the biggest challenge, which is where our organizations in terms of their own skill set with respect to data and AI skills. And what makes this problem even more complex is the fact that data is fairly fragmented. And even when the data is not fairly fragmented, and let's say you are one of those few unique organizations that have managed to bring all the data into a single data lake, I'm sure there are a few out there. The lack of knowledge of what that data really means is not fairly well understood. And so that presents yet another unique challenge for a lot of organizations in not being able to utilize data in ways that's efficient, effective to uncover new hidden insights. We all know that when you strip data away from their systems of records, you often lose that business context. And so not understanding the true meaning of the data and in the relevant context certainly hinders insight and knowledge. And we all know that AI hinges on knowledge, especially when it comes to enabling AI against your own enterprise proprietary data structures. And so what we are seeing in terms of how companies and organizations are approaching this problem with respect to enabling Gen AI inside of their own enterprise against their own proprietary data. One of the things, and this is highlighted in Gartner's recent tech impact radar for generative AI, is the fact that knowledge graphs are the appropriate targets for exploiting large language models for business value. And we know that given our own history in terms of where Stardog has grown up. We've been working very hard in terms of enabling enterprise knowledge through this notion of abstracted enterprise data vocabulary that gets captured in these knowledge graphs as a way to provide machine readable data structures that represent semantic knowledge about all the physical and digital worlds that exist within the enterprise. And so it's no surprise that Gartner has called out the notion of knowledge graphs as sort of the core foundation through which companies will achieve business value with their large language models as part of their build and data related foundational technologies to enable generative AI across the enterprise. And why is that? So for those that are sort of new to the world of knowledge graphs and what that really represents, it's really taking your data in terms of how it is structured and stored and where it's located, which is really for the purposes of efficient storage. It's structured for efficient storage. It's structured for efficient querying within that single source, but that you have data that is structured differently in different sources, different applications, and located across your on-prem universe as well as your cloud universe. that there's no consistent representation and meaning associated with a lot of that information because it all is trapped in this sort of third normal form of relational structures. And so the idea with knowledge graphs is you put an abstracted layer on top of all your enterprise data real estate and represent the meaning of that data as the actual schema through which you consume all that information. And so that's where a knowledge graph powered semantic model really provides that additional business context layer above all your data in order to make sense of all that information. And so what that really translates to then is this a unique ability for you to enable generative AI applications on top of your enterprise data landscape through the semantic layer that has business context, business meaning, and business logic represented within its sort of schema within its data model, semantic data model itself. So that enables you to then have your knowledge workers work with data in ways where they can now ask plain language questions and receive plain language answers. This is an example of what we have implemented here at Stardog, our offering called Voicebox, enabling this conversational AI for enterprise data using plain language Q&A. So rather than just me talking about it, I'll take a few minutes to demonstrate exactly what that interaction looks like. So I'm going to move into a scenario here, and I'm sort of a knowledge worker in a manufacturer, a company that I work for. I am a product quality SME at Good Beer Company. And one of the issues that I track as the product quality SME are reports that consumers have published on social media about the fact that there's reports of beer being reported as flat. Good Beer Company manufactures and distributes beer across all the U.S. ball fields and other types of large, consumer gathering types of events. And one of the things that they have highlighted is that there's a report of some beer being reported flat. Now, that can't be good for the Good Beer Company. And so as the product quality SME, I need to investigate, whether this is an issue that is to do with how the beer was, how long the beer was stored at that particular customer location. Was there something in terms of the transportation, or was there something in terms of the warehousing, or were there issues related to specific materials that were used to manufacture the beer, where the issues might lie? And you can imagine in a large manufacturing organization, a lot of these questions span a single source of truth, right? So you have to go across manufacturing, supplier, distributor, customer applications to investigate the possible root cause. Now, as a product quality SME, I really don't care where the data is stored, how the data is structured. I just want to be able to ask questions in context of this particular scenario, my use case, and be able to ask questions in plain language as I understand the representation of the information, right? So I may want to ask things like, find the consumers who provided feedback about beer being flat. And I can see that there were 3 consumers that were captured in the system that represent the feedback that had reports about flat beer. Maybe I'm more interested in understanding if there were specific distributors whose trucks may have experienced some anomalies. And again, this information sits in a different system altogether, does not matter to me as the product quality SME. I see that there was a response back in plain English that says there was one distributor whose trucks experienced an anomaly. In this case, it was Advanced Beverage Co. Inc. And if I ask the next question, I may want to ask something a little more open-ended. Tell me more about Advanced Beverage Co. Inc. And the idea here is that I don't know what trucks they are part of this particular distributor, where this information was sourced from. I can see that this information is about a distributor that was created in our systems in 2020, has a particular identifier. We can see this information was sourced from Microsoft Dynamics. And we also see that there are 2 trucks associated with Advanced Beverage Co. Inc. Now, truck 002 and truck 004. Now, I may not know which truck has an anomaly, so may ask the next question, which truck has an anomaly? Again, the idea of anomaly is understood because that's a particular concept that I'm interested in understanding as the product quality SME. But I'll show you exactly how I'm able to frame these types of questions with respect to not only the business context that I'm showcasing here, but also the appropriate guardrails. So you can see that I was able to come back with a response that said that there was an anomaly, and that anomaly was reported in truck 002. Now I'm going to ask a follow-up question. Which sensor on that truck has an output of type anomaly? Now, what is happening here is you can see that the conversation is about truck 002. But as I ask the follow-on question, I make the representation of which sensor on that truck. So I'm not explicitly pointing out truck 002 or 004. So the conversational context continues based on my previous queries for it to understand that when we say on which sensor on that truck, that it's referring to truck 002. And you can see the response here telling me that temperature sensor 11 on truck 002 has a type anomaly, right? Now, this is a very specific demo, and obviously I've well rehearsed my demos as you would expect. But the idea here, the system is intelligent enough to take variations of the same type of questions, because we all are humans and our ability to ask questions and our vocabulary certainly varies. Mine is fairly low from that standpoint. But if I wanted to say, look, which truck has an anomaly, I may ask the question, which vehicle has a problem? I'm able to, the system's able to, I should say, make the association that the notion of truck and vehicle are fairly synonymous in terms of semantic alignment, as are concepts of anomaly and problem. And so I'm still able to get that kind of response. What's also interesting is that I'm able to have full traceability behind each of these questions in terms of where these answers were generated from. But before I jump into that, I do want to show you a bit of the behind the scenes. So what's happening behind the scenes is the semantic model. I'll pull this up here for this beer demo. The semantic model here encapsulates the specific knowledge concepts that are important for me to be able to ask those questions. So concepts like distribution, selling points, customers, skids, consumers, product feedback, finished products, trucks, sensors, warehouses, equipment. So you can see this is the semantic model that is an abstracted schema that sits above my enterprise data landscape. And then once I have the semantic model, basically it's an exercise of what are important business concepts to you and how those concepts kind of interconnected or interrelated. And you cannot draw that on a whiteboard, you draw that into our system here. But then from that standpoint onwards, you essentially go back and say, where within my data estate will I find information about customers? So you can see that for customer information, I'm pulling data in from Snowflake. I see information about the specific clients that I sell to as a beer manufacturer, Wrigley Field, Indianapolis Motorway. At the same time, I'm pulling all the sensor information from Databricks. So I can pull in data about all the sensor information, the sensor readings that I'm capturing in real time within this information. Now, what's happening here is when I ask a question in my previous application, Voicebox, we are identifying specific parts of the semantic model that are aligned to the question that's being asked. And then we use the power of large language models to generate a structured query for Stardog. And then we use a federated approach where we leave data at the source. And through this exercise of mapping, at the time a question gets asked, we push queries down into those source systems to actually get the answers back. So it's a virtualized access to those systems and a federated approach in terms of getting answers across multiple data sources in this particular scenario. What's also interesting is that not only am I able to federate, and I can federate across 150 plus different systems, You can see I have in my system here access to Athena, Redshift, SQL, Maria, Postgres, Salesforce, Snowflake, Synapse, Trino. So these are some of the systems that I can connect to within my enterprise, and they can be mapped into these different various concepts. But on top of that, this notion of anomalies does not exist anywhere in my data landscape. I'm actually able to configure a business logic, which we refer to as an inference rule, that says a concept of an anomaly is essentially where we can, when a particular condition where sensor information that's being monitored on a truck exceeds a particular value of 55 degrees Fahrenheit, then we can infer that truck has an anomaly. This relationship between truck and anomaly, when I asked the question, which truck has an anomaly, back in my original input here, so you can see which truck has an anomaly, I was not able to discern that from my source data because those tables, that relationship exists nowhere in my source system. But what I can do is I can annotate the semantic model with this business logic and create this inference rule that says if a certain condition is met, then we can infer the fact that truck, it has an anomalous value and an output with the sensors information that we're pulling back from Databricks. So this is an additional layer of information and business logic that can be annotated on top of the semantic model. So not only does this help you provide the business context to the generative AI applications, it also enables me to go ahead and ensure that it provides the right guardrails for our generative AI applications. So what that means is the only questions I can ask are in the context of these semantic concepts that are represented in this model. I cannot veer outside of these concepts. And so when a question gets asked that does not exist or is not represented in the semantic model, I'm not able to answer that question, or Voicebox is not able to answer that question, essentially. And then back here, I can certainly drill down and understand more information. Maybe I want to pull in an understanding of where I'm sourcing this information about advanced beverage co-ink. This is another part of our tool application where I can kind of see the same information. I see that truck 02 is right here. I may want to expand by like what products are being packed onto that truck. I see there are 5 skids here. I may want to pull one of the skid and want to see perhaps which warehouse this information is being, packed into or stored. I can see that it's coming from our Charleston warehouse. Maybe I want to see what sensors are being monitored on that particular in that warehouse. I can see there are 2 sensors. There's a temperature sensor and a humidity sensor that's being monitored into that warehouse. So all of this information I'm pulling in from those source systems earlier that I've mapped into Snowflake, Databricks. And then I can continue my conversation that I can have, I may want to say, which customers should I notify if a particular material has been recalled in terms of the manufacturing process. So again, I'm able to take raw ingredients that are in my manufacturing process, and I'm able to come back into my customer applications and go across that supply chain and say, these are the customers that likely have some sort of an impact here. So how does this all kind of work? How does this all work from a technology architecture standpoint? Let's kind of transition back to our slides. You see a slideshow here. And again, the business context can change, right? It could be a customer 360 scenario. It could be a financial wealth management scenario. It could be a product R&D scenario. So the good news is that you can enable these GenAI applications to both have the right business context through this knowledge graph semantic layer, but also the ability to provide the right guardrails. So the way it works is we take in terms of the Voicebox itself architecture, we take in a question from a user. We identify specific concepts using the large language model that's native and fine-tuned to the Stardog application and Stardog platform that comes packaged in with the Voicebox architecture. We provide those concepts back to Voicebox to then do a vector search against the semantic model or the schema that's represented in that semantic model to say, okay, which are the likely semantic model concepts that we need in order to answer the question based on the concepts we've identified in the original question from the user. We then use the power of the large language model again, which is the step 4, to essentially create a structured query for Stardog. And then through using our knowledge graph platform, we execute a federated search where we push SQL down to the source systems in order to get those answers. Those answers are then presented back to the large language model from a standpoint of summarization, and then we summarize that response back to the user in our subsequent flow of information. So what you can see here is the fact that what Stardog Voicebox provides is this sort of native fine-tuned large language model. In fact, I'll talk about, we use multiple models here, and embedded vector search capability, orchestration of all of the agents that actually enable this flow, and of course, the core power of the Stardog knowledge graph platform. And here's a sort of a more of a multi-agent agentic view of the Voicebox architecture, from the user asking the original question with various different agents across this orchestrated layer, working in tandem to do the specific task, right? So everything from looking at chat histories, interpreting the question to identify terms, summarize the schema based on the specific semantic model concepts, to generating the query, to validating the query, to executing the query, summarizing the results, and of course, validating that the results are accurate before the response is sent back to the user. So it's a multi-agent deployment architecture that is part of the Voicebox overall implementation that we have here. So what is happening behind the scenes? Voicebox certainly uses multiple open source large language models. We don't rely on OpenAI for a variety of reasons. Many organizations don't want to bring a lot of their proprietary data into a, frankly, OpenAI is not quite open. I'm sure at this point everyone understands that. So a lot of privacy security concerns there. And then we used a variety of large language models that range from 7 billion to 70 billion parameters, depending on the specific tasks we want them to perform. And we've fine-tuned these using what we call full fine-tuning techniques, but also performant efficient fine-tuning techniques to improve accuracy for our corresponding tasks. And then the fine-tuning that we've performed is within working with our partner and working closely with that engineering team using Databricks' Mosaic ML, and now I believe it's called Mosaic AI platform. So what does that look like from a fine-tuning perspective? Mosaic has been a great sort of AI application for us. They provide several easy-to-use APIs from a fine-tuning perspective. Also, the fact that working with the Databricks and Mosaic team, we were able to access powerful GPU instances without having to worry about any capacity issues. They do come, like I said, with some reasonable default hyperparameters that allowed us to get going quickly with our fine-tuning exercise. And then for more complex use cases like the generation of the specific structured query that Stardog uses, in this case Sparkle, we were able to tweak the hyperparameters through a simple editing with a configuration file, which was necessary from our standpoint to improve the accuracy of the results. And the fact that Mosaic gave us that flexibility where we could use both full fine-tuning as well as these performant efficient techniques, which made switching between them fairly easy, again, with a small configuration change. So for those of you who are contemplating the use of Mosaic, certainly we've enjoyed utilizing Mosaic for the fine-tuning purposes. So what did that fine-tuning training architecture look like? You can again see some of the work here from a Stardog perspective, where we are creating this sort of evaluation model with training data that we run through the Mosaic platform. And we have also observability and the ability to trigger model evaluation built into this, eventually understanding what weights we get associated with specific training data, and then fetch those updated weights as part of our model evaluation, and then also take that and put that into our model serving piece, where we've used and utilized Mosaic as well as some other techniques and technology platforms for model serving purposes. So fairly easy from a deployment. perspective and utilization standpoint from a fine-tuning exercise. Additional benefits of using Mosaic. Mosaic hides the complexity of all the model parallel training, and certainly supports the sort of full, the full sharding, data parallelism aspects that are important from again, from the parallel training exercises that we're doing here. Integration with data sources like S3 and Unity Catalog, which makes it very easy to manage training data for us. Great observability support that comes with Databricks ML flow integration. Gives us the opportunity to have access to a variety of large language models that we can choose from. So while we're not necessarily vetted to any specific large language model, because our approach is to essentially choose the best one for the job, regardless of where we source it. Obviously, we work with very popular open source large language models. In the case here, we've been working very closely with the variant of Llama 2. We had the ability to test Llama 3, and we were able to quickly determine that Llama 3 wasn't giving us an inherent benefit in terms of performance or accuracy. In fact, it was quite the opposite, especially from a performance standpoint. So just those types of learnings and quickly adapting to this fast changing, evolving universe of large language models and small language models is important in terms of how quickly we can move through this and ensure that we're still delivering high performance and high accuracy from that standpoint. So lots of good benefits that came working closely with Databricks and Mosaic. And then, I will sort of leave you with this thought here. I know there is a lot of talk about RAG, retrieval augmented generation, where we strongly believe, and there's lots of proofs out there in the industry now, if you're tracking it, is the fact that RAG, while great in terms of a starting point, they're a starting point for working with documents, first and foremost, and more importantly, RAG still introduces a lot of hallucinations. And so the idea of, yes, RAG could reduce hallucinations in terms of an approach is not the same as RAG eliminates hallucinations. And partly because of the fact that RAG still relies on large language models to generate the answers. And in our case, we're not relying on the large language model to generate a response or an answer. We are using it to generate a structured query for Stardog that we can validate against the semantic model, and then use our engine to execute a federated search inside of your enterprise environment where your data stays, and a response basically is presented back to the user based on information that is sourced and traced back to your systems of records. So there's full traceability into how we're retrieving those answers, from what systems. We're not relying on the large language model to generate the answer. And of course, the other benefit of the Voicebox is the fact that it's a fully integrated solution. So this is not a do-it-yourself, does not require you to worry about procuring and I'm trying to understand what large language models you need to choose, or the training infrastructure, the fine-tuning infrastructure that has significant costs to the organization, let alone skill set requirements. And then the integration around multi-agent orchestration, the multi-turn conversational context, and a chatbot experience that's built into the Stardog Voicebox offering. Now, there is an API behind the Stardog Voicebox. If you needed to expose this inside of your own applications, you can certainly do that. In fact, we've done that recently with a release that allows you to have the same Voicebox conversation I had earlier through our Voicebox chat interface directly inside of a Slack experience. So if you are Slack users, or you maybe want to bring that experience into Teams, we can easily do that through the API infrastructure we provide on top of Voicebox. And for those that are not familiar with our partnership and relationship with the Lakehouse environment and Databricks specifically, we are on Partner Connect with Databricks. This is me coming recently from the Databricks conference. In fact, the same session was presented there at one of the innovation showcases, and just to make sure that everyone understands, for those that are Databricks users, and all the while we're not necessarily exclusive in terms of our ability to pull data out of Databricks. As I mentioned earlier, we can connect to 150 different systems. We have some good integration partnership here with Databricks to the point we're integrated with their SQL warehouse endpoint. That's the mechanism we use to push queries down to Databricks. So we don't necessarily have to move copy data from the data lakehouse and put it into Stardog. That's one of the benefits you get with using Stardog relative to another graph database vendor or provider, where the expectation is that you will move data out of your data lake or your data warehouse to pull into a graph database before you can use it as part of your RAG architecture. That is not the case with Stardog. We integrate through the Unity Data Catalog, so we have access to all the metadata information that we use to then help facilitate that knowledge construction, the semantic model construction. There's integration with Databricks Spark, so we can run large-scale data ingestion jobs. If you do want to materialize some data or you want to run in any resolution, or we again leverage the power of Databricks Spark for that. And of course, we've talked about our integration with Mosaic for the LLM fine-tuning and model serving components. And for those that are keen on getting started with this journey that I just shared with you, that I demonstrated here, we have a easy way for you to get started. There's a free option here that you can experience the same demonstrator that I just gave you using that supply chain scenario. We have multiple scenarios, including Customer 360 or wealth management or insurance, just to experience the type of interaction you can expect from Voicebox. You can get started for free. We also have a very easy low touch point for you to get started with Essentials. If you want to bring your own data for some sort of a trial experiment, this is a great way for you to kind of get going on that piece. And of course, those that are eager and ready and want to try something that is more of a pilot that you want to bring inside of a particular business functional area inside of the enterprise, we have an option for you there. We are a fully SOC 2 Type 2 compliant offering in the cloud. We also can deploy on the edge, and we have those options available as well. With that, I will take a few minutes to see if there are any questions that I can answer. I'm sure there's a few here. Let me go through the chat interface. I can go through this. And oh yes, that we did. I was reminded that there is an incentive for some of you folks that joined this webinar today, in terms of an Amazon gift card, and I'm happy to announce that incentive has gone to Martin Chen from Little Caesar. Martin, you will be hearing from Jasmeet at Stardog about those gift card details. I want to thank you again for attending. Quick question. I see that there's a question from Vasily. Navin, very informative. Quick one, please. Is Voicebox trained or generic on generic terminology, and can it be tuned? Can it be tuned? Did I lose the question? Sorry. Can be tuned to a specific domain with specialized terminology. So first of all, it is Voicebox is fine-tuned in terms of the large language model that we use in order to generate the question and answering on creating structured queries for Stardog. That's first and foremost. So we're not using Voicebox to train it on on your data. There is an aspect of the Voicebox semantic model that can be used to encapsulate your specific domain. That's what I had demonstrated with the designer tool. In fact, I'll show that here again. This is how we encapsulate your business context, your business domain. And if that includes certain terminology, yes, absolutely, right? So there's aspects where we can pull in from a vector embeddings perspective. If you have something that is pertinent to your industry that you want to bring in as part of the vector search to identify synonyms like abbreviations that are pertinent to your organization, yes, absolutely, we can do that. We can also encapsulate that within this specific semantic model that I'm showcasing here. Good question, Vasily. All right, so some question, does your system have access to Medicare, Medicaid systems? Look, we can access any system that has some sort of an open standard access capabilities built in. So JDBC is very popular. REST APIs is another mechanism we can access multiple systems. So as long as there's a RESTful interface that accesses data in those environments, or a JDBC ability for us to connect into those systems, then yes, the answer is yes, William. I have another question from Arif. For organization's perspective, considering data mesh, data management, how will the semantic layer in KG be deployed? Domain level or centralized? It's a good or some combination. I think you know the answer in your heart of hearts. You've kind of spelled it out. It is some level, some combination, right? So the good news here is that you can see I have a semantic model here that's prescribed for my supply chain scenario. I may have a different model. Let's see if I can go back here, designer, that's pertinent to, let's say, this regulatory reporting aspects, and that's a semantic model here. Or in fact, let me just pull up something a bit more interesting. This customer 360, where I'm pulling in data all, the context of the information is all around customer 360. So in that sense, it's sort of domain level, and that can restrict what parts of the system a certain users can access based on certain access rights and access policies, but also the types of questions they can ask, right? So in a customer 360 scenario, CRM scenario, I may not be able to ask supply chain question, but that's okay. Those are different set of users, and I can provide that domain level specificity here in terms of the types of question and answering they can do. But if you wanted to, there's like this notion of data mesh is exactly what Stardog can enable. Is you can then combine these semantic models to raise it to a level that allows you to have questions that go across domains. So cross-domain types of questions that can be asked for a whole host of different users. Maybe you want a certain executives access to that type of information, and they want to be able to ask those questions. So the answer is yes, a combination RF and semantic layers and knowledge graphs are absolutely suitable for a data mesh, data management type of deployment foundation. So LLMs do not generate answers. How are they used? So again, Joseph, to emphasize the fact that we are using the large language models to generate a structured query for us. So if I go back here, and I'll showcase this here from this example, when I said, show me all distributors who structs experience an anomaly, what I'm really doing is I'm generating a particular structured query here for us. So we're using the power of large language model that's been fine-tuned and is native to the Stardog platform in order to generate the specific structured query. And then we use the LLM to also, beyond the structure, the creation of the query, we're also using it to summarize the response, but that is its purpose. In order to retrieve the answers, we're executing a federated search like we do with our platform today, that goes into your enterprise source systems and gets the answers back to the users. So you have full traceability, visibility, and we're not relying on the large language model to generate the answer, and that way it's not generating any hallucinations. Hopefully that answers your question, Joseph. Ontology lookup the vector database, so the customer has to create the ontology, or will this be created out of existing documents? So first and foremost, Kian, if I'm saying your name correctly, we enable you to work very closely with your structured, semi-structured database environments, right? Application environments. So think Salesforce, think MongoDB, think Databricks, think Snowflake, think Synapse, where a lot of your proprietary information, your sensitive information exists. So that's first and foremost. And so there is an ability for us to generate an ontology from the structured sources of information. And if you have existing metadata that you already captured in a data catalog, for example, Colibra, or in fact, I'll go back here, where you have information captured in Colibra or Atlan or Unity or Purview, we have the ability to create help you create the ontology based on that understanding of that metadata. So we have the ability to harvest the metadata from the source systems as well as these data catalogs and utilize that to generate the ontology. if you wanted to go bottoms up. In certain industries and certain organizations or certain service providers come with an ontology in mind, and you have the ability to bring that ontology into the Stardog environment as well. So more of a top-down approach. And then if you wanted to create one from scratch, you can do that within our designer product here that I'm sharing in the screen. So again, good question. Let's see if I missed any. Alexis, once the query has been constructed by the fine-tuned large language model, how do you validate the Sparkle matches the semantic model? So we have, yes, so we have because we are, we follow all the open web standards for semantic technology and semantic web, and we have taken painstaking measures to ensure that Sparkle that gets generated is, first of all, syntactically accurate and correct, and then more importantly, can be validated against the semantic model. So we ensure that anything that's been generated or created, we have the ability to validate that against what's in place with the semantic model within the ontology and the shackle perhaps that's associated with that, so that there's a correctness associated with the query if there is any errors that are there. Mule, shout out to you, buddy. Good to see you active on the presentation. Let's see. Ram, what is the typical time frame for enterprises to deploy the solution, get some ROI? Ram, we've seen, we in fact have, again, taken a very measured approach here. We obviously work with you guys to ensure, or your clients, if you're a consultant, to ensure that there is a very specific use case in mind. We have what we call a 0 to 8 week engagement process, where we start from a use case and back into a semantic model, and then with 3 systems of records that you map against that semantic model to start showcasing the value through the Voicebox architecture. So, again, no choice, no worry about LLMs, or no worry about orchestrations or integrations. All of that is all built in. The exercise, the 0 to 8 week exercise, is starting from a use case, identifying the semantic concepts, modeling that in here, mapping it to your 3 source systems, and we're up and running with a use case demonstrating value in that 0 to 8 week engagement. Obviously, then from there, companies start to productionize it and scale that out to more use cases, more sources, but that comes beyond that initial 8 week launch process. Yeah, so Ram, a good question. Hopefully I've answered that in terms of the quick start packages there with the 0 to 8 week engagement. Joseph, yes, we need to use large language model to find the right partner rules in fact, which is our approach. Sort of, yes. Okay, cool. All right, so last question. The basics of getting Stardog project right is to push unstructured data and knowledge based data store for something with a schema. What about Q&A docs, etc.? I think it is the same approach from our standpoint. If the goal ultimately is to eliminate any hallucinations, right? You want some ability to provide guardrails, some business context. That is the mechanism through which, by mapping it into this sort of ontology-based data store, you're able to make this more deterministic. By definition, large language models are probabilistic, and so their purpose in life is to generate a response, whether true or not, right? So this is a great way for you to not only generate accurate answers, ensure no hallucinations, but importantly, ensure there's full trust, because you have traceability and visibility into how those answers are getting generated, what systems of records were used to generate those answers. So great question, guys. I think we're approaching the end of our presentation time. I appreciate everyone's time. I appreciate everyone's attention and questions. Happy to do any follow-ups if you want to reach out. We'll be obviously sharing this recording and presentation with you. But if you're keen to connect on any of these topics, I'm on LinkedIn. You can hit me up, Navin Sharma, Stardog, and I'm happy to connect with you there. Again, appreciate it.